Hello, my name is Hert Castillo, and this is my project one for fluid mechanics with Professor Ozbay for summer 2026. So once you're in Workbench, what you want to do is you want to grab the fluid, flow fluent, drag it onto your project schematic, click geometry, and then under the properties, switch from 3D to 2D, then right click geometry and open up new design modeler geometry. Okay. All right. Once this is loaded, the first thing you can do is just go to units, set it to millimeter because that's what we're going to be working with, and then click the arrows to go normal to the z-axis. Then go to sketching, create a rectangle, dimension it. For this, the dimensions are based off the requirements set for the project. In this case, the requirement is that the length is 150 times the height, so I set the height to 5 millimeters, and the length to 750 millimeters. Okay. And then after that, click concept, surface from sketches, then box select and select your rectangle, and then apply and generate. Now your rectangle should be shaded in. All right. Then we're done. We're not done with the geometry, so we go back to the workbench. Green check mark, so we're good. All right, and then just double click mesh. All right. So now you have the rectangle you made here. And now we are going first, before we do meshing, we're going to name our edges. Click edge here. So you click your edge, right click, create an M selection. I call this the upper wall. Just click and press N. Inlet. Outlet. And then to make sure you have the appropriate dimensions named, just go here, expand your name selections, click on it, it'll highlight what is named what, just to make sure you got it. All right. Now we're going to start the mesh. We're going to go right click mesh, insert sizing, edge click, hold control, click the top and bottom, apply the geometry, change your type from element size to number of divisions. For me, I'm going to do 3,750 divisions. This is pretty much based off your measurements, so just mess around with that and then should be able to get a good mesh. Set that to no, the capture curvature to no, and then behavior to hard, and then click generate. The meshing is going to take quite a while. So we're just gonna all right, now that the meshing is done, check, make sure it looks good. All right. Now we're going to, again, right click mesh, insert sizing. This time we're going to grab the inlet and outlet. Apply. I think I clicked the wrong things. I'm going to do that again. Edge. Size. Number of divisions. So 25. Again, the number of divisions, you just gotta play around with the number, figure out what works best. Again, put capture curvature to no, behavior to hard, and then generate. Okay, now that that mesh is done, we're going to do a third and final mesh, but this time it's going to be a base mesh. Just click shape, apply geometry, nothing else needs to be changed, and then generate. This one's quicker. Yep, all right. Okay, now that's done, go back to the workbench, right click, update, double click setup, to double precision, solver process, you can leave at 1, it doesn't really matter. Putting it to 4 for personal preference. Alright. So first thing you gotta do is expand the models on viscous, just click, double click, change to laminar because we're working with laminar flow. It's okay. Then expand materials, fluid. Depending on the project, if you want, you can just create a new fluid, name it whatever fluid, and then input your known properties. So I'm using water, a density of 1000, and then viscosity, uh, 0.001, pretty much. Change and create, yes. Okay. And then you'll see a fluid is created. Double check properties. All right. You don't have to create a new fluid. You can just use air. Then mess with the density and viscosity, however, in order to get the appropriate Reynolds number. Next. There we go. Results. Go to residuals. Then for me, I'm changing this to 1e negative 9. This is what I found worked best for me. Got the clear results. You can play around with this number to make sure you get the intended result you want. go to cell, fluid, double click surface body, ensure that the material is what you're using, click apply, close out. Okay, then we're gonna go reference values, compute from inlet, and the reference zone is the surface body. And the reference values should be what you have for your fluid. If it's not, just make sure it is. Change that. And then input, you can input the velocity here. The velocity, again, is dependent on your Reynolds number. So mess around with the velocity, make sure you are meeting that criteria. Then go inlet. We're going to change this for Couette flow. We want a pressure inlet, not a velocity inlet. And make sure to click prevent reverse flow. Then do the same thing for outlet. Keep it as a pressure outlet, but click that reverse flow, apply. Double check. Things good. Residuals, okay. Laminar, good. Not good. Okay. Next, go to the walls. For the lower wall, for the Couette flow case, you don't have to change anything. Just ensure it's still stationary and no slip. However, for the upper wall, we're going to change from stationary to moving, and then set the speed to the desired velocity. You just double checking, everything's good. All right. Oh, reference zone, surface body. Okay, then just go ahead, double click initialize it. Just making sure everything's still good. All right. Then double click run calculation. You can set the number of iterations to whatever. I'm just gonna do 500 just to ensure. Just keep this as 1 and then calculate. Okay. Should be almost finished. Okay, that's done. Just go back to the workbench. Set mark, okay. Go on to results, just double click. Alright, so now here we're going to create a midline and endline for the graph cases. We're gonna go line, just name it midline. Then half your length. But for here, convert to meters. So you should have your length here in millimeters. Just want to convert that to meters for this. Just quit samples to grid. Then click apply. Should see a line appear halfway model. Then create again, another line called the end line. Now just put as close to the length as possible. without actually putting it on. Apply. Yep. And we're going to just double click contour, velocity, location, symmetry 1. The variable, we're looking for velocity u. For contours, just set that to 110. Okay, click apply. Should get a, there we go. Now, just to make this more visually appealing, we're just gonna change that to horizontal. Precision to fixed, apply. All right. And now we're going to do the chart, velocity profile, change the type, data series, add your lines to create the new series, end line, station end line. X-axis, your variable is velocity u, and then y-axis, just put that as u or y. I'm sorry. Then click apply. So for the Couette flow, this is what you should be getting. You only see one line, but that's because both lines are overlapping. Go back to data series. See the blue line is end line. Just delete it. Apply. Red line. So yeah, they're just on top of each other. It's okay if you don't see it because they're literally on the same line. Just create that back again. And yeah, that is pretty much it. All you have to do for the Couette flow case.